Hello. All right, so today we're going to look at using function notation. Now, we've played around with functions in Python, and we defined this, something similar to this. We called it wraps. The input variable is ounces, or OZ. This is the function we wrote. Dollars equals the ratio of dollars to ounces multiplied by ounces, and the output's dollars, prints the dollars. Great. And then we'd call it the function, what we call it in this case wraps. If we want to see how much 10 ounces would cost us, we would plug that in, and then the output in the console will be 9.8. Because you're taking this number times 10, you get that. So it's the same idea with the other stuff we're going to use in math with function notation. So we're going to get some functions up here, and we'll play with them. All right, so here we have two functions we're going to work with. Wraps of x, which is 0.49 over 0.5 times x. That looks very familiar, doesn't it? And then f of x equals 2x minus a third. And we're going to see some, we're going to do some exercises with this where we're inputting a value and crunching the numbers and getting an output. All right, so here are two that we're going to work with. Wraps of 10 and wraps of 2. So wraps is just the way we call the function. Or a name for it. And so we're just going to take our wraps, we input 10, and then this will be the output. So 10 is the input, and what we get is the output. And then in this case, we get the 9.8, because if you take 0.49 over 0.5 times 10, we get 9.8. Right there. There we go. Wraps of 2. We substitute 2 in for x in our function. And then we go ahead and get that. And, oh, geez, I'm embarrassed. I don't know this one off the top of my head. But let's see. This is going to be 0.98 times 2. So I believe it's going to be 1.8. 6. Oh, no, that's not right. That can't be right. 1.96. There we go. All right. Now this, there's no context to it. It's just, that's what we get. All right, so let's do this one, f of x. Oh, we need some exercises to work with. Let's fix that. All right. Oh, my gosh. Changed color on me. Holy cow, and moved. All right, so f of 1/3, we substitute the 1/3 in for x. So then 2 times 1/3 is 2/3. And then we subtract 1/3, we're going to end up with 1/3. Because 2/3, you take away one of those thirds, you have 1/3 left. Look at that. All right. So now f of 2, let's see. We substitute in the 2 in for our variable here. Great, now we do some multiplication. 4 minus 1/3. And 4, let's see. Off the top of my head, I believe 12/3 is the same as 4. And then 12/3 take away 1/3 is going to be 11/3. All right, so there we go. There's a using function notation with some simple linear functions. Now we're going to look at a quadratic equation. Okay, here we have q of x equals x squared minus 4x minus 3. And we're going to figure out what q of 2 is. So the input is 2, and whatever we get will be the output. And so one way I think about doing this, I always want to think about like whatever we're substituting in is going to go inside of a parentheses. Squared minus 4 parentheses minus 3. And then within these parentheses we go 2 and 2 because that's what the input value is. So let's see. Let's crunch these now. 2 squared is 4. Negative 4 times 2 is negative 8. And then we have the minus 3. And let's see. 4 take away 8 is negative 4. Minus 3 is -7. So there's the output. So the input is 2, the output is -7. One way you'll see us talking about it as an ordered pair. What I mean by an ordered pair is x, y, which in this case is going to be 2, -7. The x is 2, the y is -7. Okay. Now we have one more. And here with the input is actually a binomial. That's okay. Do the same kind of idea. We take where the x was and we open up a parentheses. So we're just inputting a plus b into our parentheses. Great. So now we have some other work to do, but hey, we've inputted our unknown, in this case a plus b. Now we're just going to go and do this. So a plus b quantity squared is going to be a squared plus, let's see, 2ab plus b squared. And then for this, because what we're doing is we're taking a plus b squared, we're multiplying it together. Actually, let me go back a step and show this. All right, so I changed the color here to be black expo marker, just so we can differentiate it between the purple, the other purple ink on the board, to keep them separate, so we can kind of see where the input is. So now we have a binomial multiplied together, and this ends up being a squared plus 2ab plus b squared by foiling. This video isn't about foiling. There's lots of other videos on it, but I encourage us to ask questions if we have questions on this one. But that's, if we take these two binomials, we get this. Now we take this -4 and we distribute it into this set of parentheses. So we're going to get -4 times -a, which ends up being -4a. And then -4 times b is -4b and -3. And I encourage you to, as you're going through this, as you're going through your work, keep yourself organized on what's happening at a line, on each line. So we can just kind of make sure we can know what terms are like terms and which ones aren't, so we can add them together, which is what we're going to do now. So let's see. Now we're looking for like terms. A squared. Are there any other a squared terms? No. Let's see. Any other ab terms? No. Anything to combine with b squared? No. All right. Oh man, look at this. I think we might be done here, people. -4a. Any other a terms? Well, there's a, but this is a times b, and there's a, but that's a squared. They don't combine. Let's see, b? There's a b squared, but we're looking for a single b. No. There's a b, but it's with an a, so, oh my goodness. And then -3, there are no other constants, so holy cow, we were actually done here. Look at that. There you go. So there we go. So this is using function notation, putting in values, or substituting in values, and then seeing what the output would be. So there we go. Bye.